Today's modern Class 6 and 8 trucks utilize multi-V or serpentine belt drive systems that transmit engine torque to important accessories including the alternator, AC compressor, power steering, and water pump. On these heavy-duty applications, the multi-V belts are working harder than ever. Should one of them fail, the results could be catastrophic. Whether you're an independent or in charge of a fleet, there's no time for this type of failure, so when maintenance is due on the belts or drive components, it's the perfect time to install a Continental Extreme Duty Multi-V belt. Designed for heavy-duty Class 6 and 8 truck applications, the Extreme Duty Multi-V belt features a tough, robust construction, longer service life, and the ability to withstand extreme hot and cold temperatures. The Extreme Duty Multi-V belt exceeds SAE standards and comes with a 100,000-mile guarantee. And with advanced EPDM polymers throughout, high abrasion-resistant fabric on the outer surface, thicker rib construction, and a low elongation polyester cord, the Extreme Duty Multi-V belt has proven its durability in many OE truck and military applications. Belts have always been a common maintenance item, but today's belts and drive systems are much more complex than those of the past. Multi-V belts have multiple ribs to increase the surface contact area of the belt, and they rely on idler pulleys to route them for adequate wrap around the accessory pulleys. Spring-loaded tensioners keep a consistent force on the belt under a variety of conditions and incorporate an internal damper that controls the movement of the spring and tensioner arm to absorb shock and belt load variations that occur with changes in crankshaft speed. The drive system works the hardest when the engine is at idle, putting the greatest strain on the belt, and the tensioner must also compensate for continuous changes in tension during acceleration and deceleration. This constant movement of the tensioner weakens the spring over time, along with its ability to maintain the correct amount of force on the belt. Without the appropriate force applied, the belt cannot effectively drive the accessory pulleys, which leads to slipping and insufficient transfer of power, underperforming accessories, and excessive heat buildup in the belt. Since it's difficult to predict drive system component lifespan, relying on a periodic maintenance routine to spot and diagnose belt wear problems before a failure will extend the dependability of your fleet and heavy-duty trucks and maximize your investment in belt drive components. Take the time at every oil change to inspect the belts and drive system. Begin your inspection with the engine running to look for belt flutter or excessive tensioner movement, which is an indication that the damper components have failed. Also look at the running path of the belt for any signs of misalignment. During the inspection, look for obvious signs of belt wear, including fraying, excessive cracking, cord exposure, or worn or missing ribs. And since higher underhood temperatures can accelerate belt wear, it's also important to look for coolant leaks, damaged fans, dirty radiator fins, or anything that can affect cooling system performance. Engine warning lights, such as a charging system or engine temperature lights, could also be an indicator of a belt or drive system problem, and any type of belt noise means it's time to take a very close look at the belt and drive system. While noise or slip might be caused simply by a belt with a worn rib profile, obvious wear with today's modern EPDM rubber materials is sometimes harder to identify. The V profile will wear into a U profile, thus reducing full contact with the pulley grooves, causing slipping and noise. But keep in mind that belt replacement in this situation may not always solve a noise problem. Worn pulley bearings, pulley misalignment, a worn tensioner, or road debris that has lodged in pulley or belt grooves can cause belt slippage and noise, and eliminating slippage is critical. Note the position of the tensioner on its centering gauge. The tensioner should be operating at its center, which is an indication of proper tension. Off-center indicates the tensioner has weakened or the belt has stretched. Fluid contamination is also a frequent problem. Coolant leaks can cause belt slippage, and belts exposed to petroleum-based fluids can experience softening of the rubber, causing the belt to weaken, delaminate, and experience accelerated wear. For the ultimate in fleet dependability, consider a comprehensive maintenance plan by replacing all components, including the belt, idlers, and tensioners. Not only will the cost of replacement over a single maintenance be less than replacing each individual component over separate visits, but it will extend the efficiency of your fleet operations and allow you to maximize the benefits of the Continental Extreme Duty Multi-V belt. Thanks for watching.